Good evening, students. Today, the topic that we are going to cover is known as trigonometric ratios. Now, what is this trigonometry? Trigonometry is a specific branch of mathematics which deals with angles and sides of a right angle triangle. I believe you can see a right angle triangle in your screen right now. The triangle is ABC. You can see angle B is a 90-degree angle. Also, you can see that I have given a specific name to this angle A, which is theta. In this class, we will be denoting angle A as theta only. Let's just study some terminologies about this particular triangle, this right angle triangle. We all know that in a right angle triangle, hypotenuse is the longest side of this triangle, of the triangle. You can see in this particular triangle, AC is the longest side, which can also be named as hypotenuse. Now, which is base? The side adjacent to angle theta. Since we will be discussing about angle A only today, or angle theta, so we will be talking with respect to angle theta. So for angle theta, the base is side adjacent to angle theta, which is AB, and perpendicular or height is the side opposite to angle theta or side opposite to angle A. These are some terminologies about this particular right angle triangle. Okay. Now, what is this trigonometric ratios? Trigonometric ratios gives you the relationship between sides and angles of a right angle triangle. There are some functions in trigonometry. These functions have certain relationship with the ratios of the sides of the triangle, right angle triangle. Totally, there are three functions in trigonometry: sine, cosine, tangent, cosecant, secant, and cotangent. These are the six functions. In these six functions, the first three functions are the primary functions: sine, cosine, and tangent. The other three functions, which is cosecant, secant, and cotangent, are the derived function. You can also name these functions as sine, cos, tan, cosec, sec, and cot. You can use the short form of it. What is this functions? How are we going to get the functions, and how do we derive these functions? So as you can see in the screen, on the right hand side, you can also see the prototype of a triangle which we have made in our first slide. You can see sine theta. First of all, let's talk about sine theta. Sine theta is side opposite to angle theta. Which is the side opposite to angle theta? BC, or height, or perpendicular, divided by hypotenuse. We all know hypotenuse is AC. So BC upon AC will be sine theta. What is cos theta? Side adjacent to angle theta, which is the base of this right angle triangle, AB, upon hypotenuse, which is AC again. Now, tan theta, side opposite to angle theta divided by side adjacent to angle theta. Which are these two sides? Opposite to angle theta is BC, and adjacent to angle theta is AB. Okay, now we have discussed about three primary functions of trigonometry. Now let's talk about the three derived functions as well. So as I already told you that these other three are the derived function. So cosec theta is nothing but the reciprocal of sine theta, which means hypotenuse about divided by side opposite to angle theta, which is equals to AC upon BC. Now sec theta is the reciprocal of cos theta, which is hypotenuse divided by side adjacent to angle theta, is equals to AC upon AB, again as you can see in the triangle. Now cot theta is the reciprocal of tan theta, which is side adjacent to angle theta divided by side opposite to angle theta. Basically, cosec, sec, cot are the reciprocals of sine, cos, and tan. That's what we have to remember. These are the things that will be useful in our questions. Okay. So we know how we can get the sine theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. Now there is a trigonometric ratios tables. There are some specific angles for which there are predefined values of sine, cos, tan, cosec, sec, cot, which we will be using in our questions. Usually we will be using these angles only: 0, 30 degree, 45 degree, 60 degree, and 90 degree. You can see in this table, if you can note certain things, if you can observe certain things in this table, you can see the value of sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, and sine 90 is 1. Why I asked you to observe this table is because we have spoken earlier as well that cosec theta is the reciprocal of sine theta. So now you can see in the table, in the values as well, you will find the value of cosec theta exactly as a reciprocal of that particular angle of sine theta. You have to learn these values of these angles for each and every function so that it will be easier for you while you will be solving questions. Okay, so now let's talk about some certain applications of this trigonometric ratios. The usual application, the major application is measuring heights of towers and mountains. We can easily measure the heights of towers and mountains with the help of trigonometric ratios that you will be learning in your next topic, which is heights and distances. Now, the second application is finding distance between planets and other celestial bodies. We can obviously cannot measure the distance of planets and celestial bodies with a measuring tape, obviously. So we also use trigonometric ratios to find the distance of planets and celestial bodies. Now, the third application is determining power output of solar cell panels at different inclination. We all know that solar cell panels are inclined in different angles. So with the help of this trigonometric ratios, we can basically take the what is the best angle to get the maximum output in a solar cell. Okay, so that's about it for this particular topic, this trigonometric ratios. I believe you have understood it. Have a nice day.